In problem number 1, it says a baseball is thrown vertically upward and feels no air resistance. As it is rising, we notice the following. We notice that the momentum as time goes by and the ball is going downwards, we have a new momentum each time, so it's decreasing. Now, as we know that the change in momentum is going to be equal to the force times the change in time. In this case, we see that there's a force that is going downwards. In this case is mg delta t, or change in time. So as the ball is reaching to the top and it starts to go downwards, we notice that the momentum as time goes by is going to decrease, and decrease. So that means that the momentum is not conserved at all. Now, regarding with the kinetic energy, we start going upwards. The ball rises to the air, and once it gets to the top, we find that kinetic energy, it stops for like a millisecond and is going to equal 0. So from the moment it starts rising, we notice that the weight is going to be negative, and therefore the change in kinetic energy is going to be negative. Now, as it starts to go down, in this case, it's going to be the opposite. The weight is going to be positive, and so is the work. So that means the change in kinetic energy is going to be positive. As we saw in this problem, the kinetic energy is not conserved either. So nor the momentum or the kinetic energy are conserved at all. So that means that our answer is going to be the following. The answer is D. Its momentum is not conserved, but its mechanical energy, which represents kinetic energy plus potential energy, is conserved.